Hello, my name is Don Adams, and this video is about light wave degradation and propagation from the standard color towards the red Doppler shift, and why the universe isn't expanding as fast as they feel that it is. In my theory, what we have here, if you look, is the radio frequency spectrum. And we're starting at terrestrial gamma rays, and then we slowly work our way down to the light, and this is what we're talking here. Now, in the light spectrum, what they're doing to determine that planets are moving away from us is looking at the color of light that's coming back at us, and if that light is shifted toward the red instead of towards the infrared, that means that the object is moving away. What the Doppler effect is looking at waveforms, you get that oscillation like this. And if you're moving with the waveform or towards the waveform, you're going to move this direction and the waveform is going to get faster. The frequency of the waves are going to become faster because you're moving against the wave in the direction that the wave is coming from. If you go the other way, if the wave is moving away from you or you're moving away from the wave or both, these are going to spread out. So in sound, you hear a higher pitch as it's coming toward you or you're going toward it, and you hear a lower pitch when it's moving away from you or you're moving away from it, or both. In the spectrum, RGBY, or RGBIV or whatever, if you're moving toward it and it's moving toward you, you're going to be shifting towards the ultraviolet. The other direction, if it's moving away from you and you're moving away from it, it's going to shift toward the red. I'm not sure exactly how they determine what color the light from the star typically is. Our sun, for example, gives off a majority of yellow light. In my theory, the further a wave travels in light years, the more it degrades. Now, in science, they haven't shown any degradation in the frequency of a waveform. But if you think about how waveform propagation works, over extended periods of time, eventually your medium is going to change. It's not going to be consistent all the way from source to destination. This change should be an average aggregate over the entire period because we're looking at an extreme distance from Earth to the nearest galaxy. In this distance, that light wave is going to come across areas of what I call subatomic matter, what science is currently labeling as black matter. And this black matter is going to slow down that or lengthen that. So it's going to shift automatically towards the red. So I feel in the calculations for the expansion of the universe that they don't realize that light can degrade and its frequency lower. They are assuming that through the terrestrial tests that they've done on short distances that waveforms don't degrade. They stay the exact same frequency, though the power, the distance between the top of the peak and the bottom peak reduces at a known rate because of, it propagating in a distance away from the source equally in all directions. We can mathematically formulate the loss of energy, though there'll be slightly more than just that. That would assume that we were in a complete vacuum. Now, as you move down and the waves get longer and longer, below radio, waves no longer propagate in a vacuum. because now you're getting into sound, supersonic sound, things dogs can hear, all the way down to lower frequencies that humans can't hear, like 60 hertz, the frequency of electricity in the United States. So basically, in my opinion, light is going to shift toward the red. The further away it is, the bigger that shift. That doesn't necessarily mean that that object is traveling further away utilizing the Doppler theory. I think most likely the universe is in a near equilibrium, and if we calculate those distances on average and subtract out the redshift, what we should get is the amount of loss per light year in frequency. So then we would know that light coming from, let's say, 100 hertz when it travels 100,000 light years is now at 99 hertz. And then utilizing that into the calculation, we can recalculate the actual motion and expansion or contraction of the universe. Thank you for your time, and I'm looking forward to your comments.